Hey, hello, Professor. Welcome to my last presentation. Today I'm going to present the next step of the clustering and the decision tree project. Today we're going to talk about what is a random forest. As you know, my name is Joshua Rocha. Let's get started. First of all, you ask us to show a video how to run it. This is my little video. Uh, this video uses the movie night that it shows at the start. As an analogy, that instead of one person deciding the film, many friends vote, just like multiple decision vote, trees vote. This is made to improve accuracy. One tree can be wrong, biased, or overfitted, but many trees reduce this error. The random forest, you say, is made up of many individual decision trees, and each tree gives its own classification or prediction. This helps us choosing the results that most trees agree on. Each tree is a different sample of the data. This technique is called bootstrapping. By training trees on different subsets, the model learns more robust patterns so we can get more clean data. Okay, let's go with important information before going in deep into my project. Trees don't use all the variables at once. The algorithm randomly selects subsets of features for each split. These random forests help us to reduce the overfitting, which happens when a single model learns too much noise from the training set. By combining these multiple trees, the final prediction becomes smoother and more generalizable. The majority vote is a mechanism of how the final answer is chosen. If most trees predict that class A is the best, the random forest outputs the option A. This random forest can be used for classification and regression, depending on the target we are trying to predict. This is my dataset, Seoul bike sharing demand prediction. The target of this was to predict the demand for share bikes in Seoul based on various environmental factors. My dataset contains information about the weather, temperature, humidity, wind speed, visibility, dew point, solar radiation, snowfall, and rainfall. This helps us to know the number of bikes rented per hour and the date of this information. Here are all of our variables. Okay, first of all, just to give you a little of context for the clustering, we use the hierarchical clustering technique to help us group observations step by step, building a hierarchy of these clusters. The goal was to identify the hours and the weather conditions that show similar rental patterns so we can select different clusters and under which conditions which people rent more bikes. We use hierarchical clustering because you don't give the clustering numbers at the start of the exercise. You have these values of clustering after. That's why we use hierarchical instead of k-means. That is the most popular one. This hierarchical clustering is useful when we want to see the relationship between observations, identify natural diversions in the data, and get an overall idea of the data structure. This is the hierarchical clustering dendrogram that we got. We got three different clusters, and each cluster represents a different type of buyer when it comes to renting these bikes. The first cluster shows us that there's a group of people that uses highly the bikes. Whenever they have a good weather, the warm temperature is there, and they have a big solar radiation. These are the guys that use the highest rented bike count. Then we got group two. They are the ones that use it when the temperature is medium and the humidity is there. Some are radiation, but not extreme. These are the second group. And then lastly, we have the third group. That are the ones with low demand and when there's a bad weather. Okay, then let's go a little with the decision tree. Decision tree is a supervised machine learning model that uses a tree-like structure in order to make predictions or classify based on series of questions. It starts with the root nodal that we're going to show it a bit later, which has internal nodes that are the questions or conditions used to determine the results, and the leaf nodes that are the outcomes or predictions that you can do along the way. These decision trees are used for a variety of tasks, including classifying data and making predictions in field, just like medicine or finance. How does decision trees work? Decision trees have a root node, it is this one, that they represent the entire of data. Then we have the subnodes These nodes that have another subnodes. Then we have the decision nodes, that is whether you choose is this one's a terminal or non-terminal. Terminal nodes, it's the end of the decision trees and narco nodes or leaf nodes. Then we have child and parent ID subtree. The process, this works by selecting the best questions to create each subsequent subset. This is just a little idea of how the structure of these decision trees work. This was the decision tree we got. We have different results, but it's basically the same patterns that I just explained you with the three different people. The Python shows us that there's an impurity reduction. For example, the root node started with a Gini of 0.49, meaning the dataset was highly mixed. Python produced two groups with Gini of 0.1 and 0.10, showing cleaner partitions. This Python shows information gains from 0.49 to 0.22. This means that the question was a stronger separator. We have three levels of a Gini, and we have a Gini of 1.0 after we do the whole process, making sure that the model is successfully organized, the data is clean, and we have these three numerical results that validate the full logic of a decision tree. The impurity decreases at every stage, and the leaf shows stable, consistent predictions, proving that our model is correctly implemented. Then, after the clustering of the decision tree, we see cluster labels to the data set and export it. We divide it into into 5 steps. I'm just gonna show you a bit of how it goes for each one of it. This clustering generates insight only if you can relate the labels back to the real data. I mean, we need to make sure they make sense. Okay, we prepare the data set for the decision tree. We divide it from the steps that I just showed you. I'm gonna show you the actual data set. This is the random forest, but it's a bit ahead. I will show you Python, just so you can have a bit more comprehensive idea. In step 16, we fitted the model using the training data to learn which environmental variables predict demand levels. Then we build multiple decision trees and average them to improve accuracy and reduce the overfitting. Then on step 17 and 18, we use the model to predict demand categories on data that was not used during the training. This helps us verify if whether the model truly learned the patterns or just memorized the data. Then we train a smaller random forest for easy visualization using metrics such as accuracy, confusion matrix, and a classification report. We measure how well the model was actually being classified. These metrics help us to determine the reliability of the predictions in real operations. Then we got to interpret these results. The most important variables were the temperature-related features, confirming that weather strongly affects the bike renting behavior. The decision boundaries found by the model are logically aligned with the user comfort and climate conditions. This was our little simplified random forest. Here you can see the hours used, the Gini, which samples we used, the values we got. I'm gonna let it here so you can sink it in. Watch it for a second. This was the code. Now it looks amazing. Then at the end, we have model implications, business implications. This model finally can be used to forecast demand, allocate bikes efficiently, and prepare maintenance and staffing plans. It also highlights the demand drops in specific weather thresholds, enabling a proactive planning and marketing. So this can only tell us that depending on the weather is the bike demand. Here's a little data set. Let's go back to the slides for a second. We can see at the end that this model helps us identify the splits. At the hour point, we can see that the dew point and the temperature is the most influential variable in order to get these results. The Rodno uses the dew point when the temperature is equal or less than 8.55 degrees as the first decision boundary. Then we have that after the dew point, the temperature becomes the second highest determinant. Here we can see the threshold of the temperatures, confirming that the colder it is, the fewer bicycles are rented. This structure tree aligns essentially to real-world behavior with cold temperatures, less demand, comfortable temperatures, more demand, peak rental hours, higher demand, where discomfort, they suppress the rents. Finally, the low Gini values in the later nodes make a strong decision separation. Branches near the bottom show Gini values close to 0.4 or 0.11, meaning the model can become very confident in order to determine these rentals. Um, this is much or less about our work. I'm really happy because I learned a bit of Python. I learned how to actually look my way around Python when things aren't going around. This was a fun project for me because we will get to make teams and learn a lot from each of our classmates. I'm very thankful for the opportunity to go across this subject. This was very interesting. I really enjoyed how demanding this was for me. I hope to have another project that makes me want to actually do the homework again. Thank you, Professor.